Welcome, dear learners. We are starting a new course entitled Inorganic Chemistry 1. Now let us have a brief description about this course. The course name Inorganic Chemistry 1 is a 4-credit course, and this course is for UG first semester students, that is undergraduate first semester students. The academic level of the course Inorganic Chemistry 1 ranges between 100 to 199. The entire course spans over 80 modules. That is, this course will be completed by 80 modules. These 80 modules include video sessions, live lab demonstrations, live classes, etc. The entire course comprised of 5 units. These 5 units include laboratory demonstrations also. Now, we are starting the course now itself. The course journey is starting. We are beginning from Unit 1. Unit 1 is entitled Chemistry as a Science Discipline and Scientific Analysis. In the present module, that is module 1, is entitled as Chemistry, a Scientific Perspective. In this module, we are discussing the following matters. First of all, introduction to science, history of chemistry, significant contributions leading to development of chemistry, branches of chemistry, and role of chemistry as a central science. First of all, introduction to science. You all familiar about science. Without science, our day-to-day life is nothing or meaningless, because in every aspect of our day-to-day life, there is science, there is chemistry, there is different branches of science. We are that much close to science. So, the question begins, what is meant by science? Science is a systematic way of learning about the world around us. And this learning is through observation, asking questions, and experimentation to find answer to the problems. That is, the science resides on observation, asking of questions about the different things around us, and experimentation to find answer to the questions. Science is a systematic way of studying the natural and social world through evidence-based observation and experimentation. In science, we are believing things only based on evidences. So, science is a systematic study which is purely based on evidences, observation, as well as experimentation. Science uses systematic methodology which includes the following. First one, observation, then measurement, followed by experimentation, followed by induction, then repetition of experiments, and critical analysis. So, the entire science branch proceed through, sift through these steps. Observation is there, measurement, experimentation, induction, again doing the experiment, that is nothing but repetition, and critical analysis of the obtained data after experiment. These are various stages in the systematic methodology of science. We can move on to each and every stages in detail. First of all, scientific observation. What is meant by scientific observation? We are observing some phenomena. We are observing something very seriously. This is highly important as far as the entire branch science is concerned. So, a scientific observation is a sensory experience about a natural phenomena that can occur in a lab or in nature. For instance, we heard about the natural phenomena of tsunami. We all are scientifically observing the phenomena with very studious mind and with very critical thinking. And we are observing each and every natural phenomena or some phenomena that may occur in the chemical laboratory or in the physical laboratory, or whenever we are dealing with some biological systems. If we are seeing some natural phenomena, we have to observe it very carefully. That is the first part of systematic way of studying science. Now, the second part is scientific measurement. A scientific measurement is a technique for clearly and concisely conveying an observed value. For example, we are measuring the weight of a body. The weight can be measured with the help of an analytical balance. The volume can be measured with the help of a measuring jar. The thickness can be measured with the help of a screw gauge. And there are so many instruments. Temperature can be measured with the help of a thermometer. So, after observation, another part of systematic way to study science is scientific measurement. We can say a scientific measurement is a technique clearly and concisely conveying an observed value. Now, next stage is scientific experiment. What is meant by a scientific experiment? A scientific experiment is a procedure, is a laboratory procedure that tests or check a hypothesis or determines if something is likely to work or not. We are performing some reactions. For instance, we have to check whether aluminum has to be reacted with hot water or not. For that, we are taking a piece of aluminum, then react it with the hot water and observe the things. What you are doing now is a kind of experiment. Instead of this aluminum, you can also use sodium metal. You are performing again another experiment. So, we are doing all these experiments to check whether something will occur or not. That is the significance of scientific experiment. Now, scientific induction. This is a very important part of the study of science. Scientific induction is a method of reasoning that involves making generalizations based on a set of observations. In order to arrive at a scientific induction stage, we have to perform a series of experiments, and we are consolidating the results of the experiment, and inductively we make critical thinking to arrive at a certain conclusion based on the observations we got as a result of the experiments. Another stage of study of science is repetition. Repetition in science is the process of repeating experiments to verify the results. And this also helps in identifying errors and increases the likelihood of an accurate conclusion. For example, we are doing some reactions between two substances A and B. Suppose we got a new product C. If it happens once, we have to repeat the experiments several times. This is to make sure that there will occur a reaction between A and B to produce C always under ordinary conditions. So, repetition of experiment, repetition of similar type of experiment, same experiment many times, all the steps are very essential in the study of science. Now, the last part in the study of science or the discussion in science involves critical analysis. Critical analysis in science is a detailed examination and evaluation of scientific work, including the research, ideas and conclusions. So, we first observe something, we have to do some experiments, again we have to do some repeated experiments, and before arriving a final conclusion, we have to consolidate all the data and examine the data carefully. What we got, we have to assess the things very carefully, critically evaluate the data before arriving a final conclusion. So, the critical analysis is one of the most important and final stage of scientific study. Now, we are discussing the history of chemistry. You know the fact that chemistry is a most popular branch of science which originated from several experiments which pass through several stages. Till date, chemistry is developing. Every day there are new inventions, discoveries. We are correcting some experiments. New experiments are coming. So, the branch chemistry has a profound history also. Within the coming few slides, we are discussing the history of chemistry. And through this, we will get an idea that how chemistry evolved as a branch as of today. Thus, we can enter into the history of chemistry. The history of chemistry is long and spans from ancient times to the present day. History of chemistry comprised of many stages. We discuss some most significant stages here. The stages include ancient chemistry, that is the prehistoric period to 500 CE. The next stage is alchemy stage or alchemy period, that spans between 500 to 1600 CE. Next stage, next developmental stage, next historical stage of chemistry is the birth of modern chemistry. That happens in the year range 1600 to 1800. Now, 19th century advances. Whenever we analyze the history of chemistry, we can say the fact that huge developments in the branch of chemistry occurred in 19th century. That's why we place 19th century advance as a separate era in development of chemistry or history of chemistry. Next part, and this is probably the last part which describe the history of chemistry, that is nothing but 20th century and beyond. Thus, on a sum, it is possible to study the historical developments of chemistry in 5 periods, in 5 stages, which include ancient chemistry, alchemy, modern chemistry period, 19th century advance, and finally 20th century and beyond. We can move into somewhat details of each and every stages, historical stages in the development of chemistry. The first part is ancient chemistry. As we know, the period of ancient chemistry is from prehistoric period to 500 CE. Early humans, that is humans lived in this era, practiced the basics of chemistry in the form of fire use. They produced the fire, but they don't know the chemistry behind it. The fire is produced from wood. They produce the fire from wood. Wood on reaction with oxygen produces fire. As a result of this reaction, carbon present in the wood, which can be abbreviated as CX. CXHY is the simple molecular formula representation of wood. It on reaction with atmospheric oxygen, that is combustion or oxidation, carbon is completely oxidized to carbon dioxide and hydrogen is oxidized to water. So, during combustion of wood, fire is produced, and this is the chemical reaction that occur during the combustion of wood. So, the pupils lived in the period from prehistoric age to 500 CE produced fire from various sources like wood, and they practiced basic chemistry because the production of fire is a chemical reaction. Now, another important aspect of ancient chemistry is metallurgy. You know the term metallurgy, the complete production of pure metals beginning from its ore is termed as metallurgy. Pupils in the ancient era, ancient period, are developed several metals, produced various kind of metals like gold, copper, etc. from their ores. So, they proved their capability in the field of metallurgy. Metallurgy is recently a very important branch of chemistry. In the Bronze Age, copper and tin are isolated by the pupils at that period, and this is obtained by heating the ores, their corresponding ores of copper and tin. The ores appeared as rocks. They heated the rocks or simply the ores and produced the copper and tin. Moreover, copper and tin combined together to produce the alloy that is bronze. At the ancient pupils lived at the ancient age prepared bronze. So, that period is simply termed as the Bronze Age. So, first they prepared copper and tin, then they prepared the alloy bronze. Next age is the Iron Age. After the Bronze Age, there is Iron Age. In the Iron Age, they prepared iron, isolated iron, and they found that the metal iron is having higher melting point than copper or tin. This is happened in the Iron Age. So, in the ancient chemistry period, there was fire, metals and metallurgy. There was Bronze Age, there was Iron Age, etc. Now, in the ancient chemistry period, the Greek philosopher Democritus, who lived in the range 460 to 370 BCE, introduced the concept of the atom as indivisible particle. Actually, you know about John Dalton's atomic theory, various models of atom, etc. But at the ancient chemistry period, the Greek philosopher Democritus just introduced the concept of atom. He introduced the concept of atom as individual particles or indivisible particles. But this concept, his concept of indivisible particle, cannot be proved, or he is unable to prove his theory scientifically. Now we are moving on to the second important stage in the history of chemistry, that is the period of alchemy. The period of alchemy is around 500 to 1600 CE. Alchemy originated actually in the country Egypt. In Egypt, it was associated with the mysticism and the transformation of matter. The alchemists believed in mysticism and they give extreme importance for the transformation of substance from one to other. That is for the transformation of matter. The alchemy branch spread into Islamic world. It happens from Egypt. It begins at Egypt. It spread to Islamic world and then spread to European countries, blending, combining together the mystical concept, philosophical concept and experimental practices. So, during the developmental stage of alchemy, three components are blended together, that is the mysticism, philosophy and experimentation. Goals of alchemy was very significant. Their most important goal is turn fewer valuable metals into most precious gold and silver. So, they believed in the transformation. They tried to convert cheap quality starting materials, fewer valuable materials into more valuable gold and silver. And next goal of alchemist was to find elixir of life. Elixir of life means providing eternal youth. The pupils at that time, or alchemist, tried to explore, tried to find out something which may offer eternal youth to them. Elixir of life implies eternal youth. The second most important goal of alchemist was to find elixir of life, that is to find some materials which can provide eternal youth. European alchemists discovered substances like sulfuric acid, alcohol, and aqua regia. Aqua regia is a material, you are familiar with that. In recent days, it is used as a solvent to dissolve the metal gold. Aqua regia is a combination of nitric acid and hydrochloric acid. Nitric acid and hydrochloric acid in 1:3 ratio mixed together. Concentrated nitric acid and concentrated hydrochloric acid are mixed together in 1:3 ratio to produce a solvent that is nothing but aqua regia. Aqua regia can dissolve gold metal. So, alchemists, especially from European countries, discovered substances like sulfuric acid, alcohol, ethanol, and aqua regia. Now, the third stage in the development of chemistry, in the history of chemistry, that is the birth of modern chemistry. The birth of modern chemistry happens in the period 1600 to 1800. Chemistry transformed from mystical alchemy to a scientific discipline. This transformation happens during the birth of modern chemistry. There was some key contributions happened during this period. Some important contributions that happened in the modern chemistry development period are from Robert Boyle. His book, Skeptical Chemist, emphasized experimental method and rejected previously existing Aristotelian elements. So, the contribution from Robert Boyle appears in his textbook, The Skeptical Chemist. Now, the contribution which leads to the development of modern chemistry is from Anthony Lavoisier. His period is from 1743 to 1794. Lavoisier identified oxygen's role in combustion, named the element oxygen, named several other elements, and formulated law of conservation of mass. What do you mean by the term law of conservation of mass? Substance can never be created nor destroyed, but one form of matter can be transformed into other. This is the law of conservation of mass, which is put forward by Anthony Lavoisier. Now, 19th century advances. This is another stage in the history of chemistry. In the 19th century, there occurred several developments in chemistry like atomic theory, which was put forward by John Dalton, who lived in the period 1766 to 1844. The periodic table of elements was first put forward by Dmitry Ivanovich Mendeleev. The period of Mendeleev is between the year 1834 to 1907. Another significant contribution that happened during the 19th century advance is the development of organic chemistry. Friedrich Euler synthesized urea by heating ammonium cyanide. This occurred in the period 1828, and this conversion of ammonium cyanide to urea marked the birth of a new branch of chemistry that is nothing but organic chemistry. So, all these are some important 19th century advances. Now, we are discussing the present stage and 20th century and beyond. This period witnessed following new branches of chemistry like quantum chemistry. You know about quantum mechanics, quantum chemistry, etc. We are giving more emphasis to theoretical aspects of the chemistry here. Next one is biochemistry. Biochemistry is elucidated as a special branch in chemistry during the last stage, that is 20th century and beyond. Biochemistry deals with the chemistry of biological systems. And the next one is polymer chemistry. We have synthesized several kinds of polymers, exploring their physicochemical properties, developed several applications, etc. So, the study of polymers, the chemistry which deals with the study of polymers is nothing but polymer chemistry. Environmental chemistry and nanotechnology or nanochemistry are two recently developed but most promising branches of chemistry. Thus, there are 5 important stages in the history of chemistry. Now we are focusing significant contributions in chemistry which helped in the development of chemistry as a scientific discipline. The significant contributions include development of atomic theory by John Dalton. This happened in the year 1803. John Dalton's atomic theory is one of the most important theory which describes the nature of atom. Even though it has several pitfalls, this theory was a highly successful theory to explain the nature of atom at that period. Synthesis of urea by Frederick Euler. This occurred in the year 1828. This is a significant contribution in the development of chemistry. This is because Euler converted ammonium cyanate. Ammonium cyanate is NH4CNO, ammonium cyanate. This is purely an inorganic compound. This ammonium cyanate, on strong heating, converted to a new compound, that is NH2CONH2. This is urea. So, Frederick Euler prepared urea by heating ammonium cyanate. This leads it to the neglection of a theory that is called the vital force theory. By this experiment, Frederick Euler proved that vital force theory is a wrong concept. What is the statement of the vital force theory? The vital force theory saying like this: behind the formation of every organic compound, there must be a vital force. But here urea is an organic compound. It is prepared without any vital force. Frederick Euler simply heated the inorganic compound ammonium cyanate, and organic compound urea is produced without any vital force. So, by this experiment, the vital force theory was neglected or rejected. Another significant contribution is the discovery of aspirin. You are very much familiar with the compound aspirin, which is used as an analgesic, which is nothing but acetyl salicylic acid. The discovery of aspirin was made by Charles Frederick Gerhardt in the year 1853. Another significant contribution is from Dmitry Ivanovich Mendeleev in 1869. He put forward the periodic table of elements. Discovery of electrons by J.J. Thomson in the year 1897 marked another significant contribution in the development of chemistry. Discovery of nucleus by Ernest Rutherford in the year 1909 is also a significant contribution. We are discussing branches of chemistry. You know, the branch chemistry as such is a very big branch of science. Therefore, it is customary to divide the big branch chemistry into several branches. This is for the sake of scientific study in chemistry. The major branches in chemistry are organic chemistry. As you know, organic chemistry deals with the compounds of carbon, the study of the properties of carbon and its compounds. Now, another branch is inorganic chemistry. Here we are discussing simple inorganic molecules, complex inorganic molecules, coordination complexes, etc. Physical chemistry, which is the branch of chemistry which has a strong interface with the physics. We are dealing with the physical transformations, energy concepts, thermodynamics, kinetics, etc. in physical chemistry. Another branch of chemistry which give maximum emphasis to analysis is nothing but analytical chemistry. Here we are dealing with the various kind of analysis such as qualitative analysis, quantitative analysis, etc. Another important branch is biochemistry. Biochemistry deals with the chemistry of biological systems. We are familiar with the fact that so many chemical reactions occurring inside our body as well as in animal body as well as in plant body, etc. The branch biochemistry deals with such kind of reactions, various factors, biocatalysis, etc. Another important branch of chemistry is industrial chemistry. You know the fact that chemistry is highly related to industry. Industrial production is very essential in the development of modern civilization. We are generating so many compounds industrially. Cement, sulfuric acid, paint, so many compounds are developed industrially. For industrial process, in order to achieve various industrial process, there must be study of chemistry or there must be intervention of chemistry there. The branch of chemistry which deals with the reactions and conditions associated with the industry are termed as industrial chemistry. Another most significant branch of chemistry is environmental chemistry. That is the process. We are discussing the environmental process and the chemistry behind it. Environmental pollution, prevention of pollution, etc. are different subset of the branch environmental chemistry. Now, we are discussing the role of chemistry as a central science. We know the fact that chemistry is a most important branch which has roots in other different branches also like physics, like biology, etc. In a similar way, all other branches of science are closely connected to chemistry. Now we are focusing on what is the role of chemistry as a central science. Foundation for understanding matter and energy is provided from chemistry. Chemistry bridges natural science and applied science. So, chemistry acts as a bridge between natural science and applied science. Development of new materials like nanomaterials and new technologies is beginning from chemistry. Advancement in medicines and pharmaceuticals is the most significant contribution of chemistry. Without medicine, our daily life will be very difficult to sustain, or the sustainability in earth, the living in earth without medicine is a difficult task. So, medicines and drugs are various kind of chemicals. We all are developed in some laboratory. So, without medicines and pharmaceuticals, the human life is very difficult. So, the major contribution from chemistry is in the form of medicine and pharmaceuticals. Now, chemistry supports agriculture as well as food safety. We are finding new, more effective pesticides and manures which support agriculture production. Food security, we can find so many methods to check whether there is adulteration, contamination, etc. So, chemistry support agriculture and food safety. driving innovations in energy. For instance, solar cells is an energy harvesting device which convert light energy to electrical energy. The intervention of different nanomaterials prepared by chemical methods improves the efficiency of such solar cells and energy harvesting devices. This chemistry branch enabled analytical techniques across different disciplines. So, analytical chemistry has its roots, has its connections in several other branches of science. Critical for industrial and economic growth. The branch chemistry and its contribution to economic growth and industrial growth is remarkable. By some suitable chemical reactions, it is more easy to prepare some compounds industrially. That industrial production increase economic growth of a country. So, the branch chemistry has relation to economics also. So, our branch chemistry is a central branch of science which has close relation with all other branches of science. That all about the present discussion. Have a very nice learning experience. Thank you.